Albert Einstein told us that mankind invented the atomic bomb, but no mouse would ever construct a mousetrap. He had a point, and I'll tell you some facts. What is atomic bomb? A nuclear weapon is an explosive device that derives its destructive force from nuclear reactions, either fission or a combination of fission and fusion reactions. Both bomb types release large quantities of energy from relatively small amounts of matter. Testing and deployment. Nuclear weapons have only twice been used in war, both times by the United States against Japan near the end of World War II. On August 6, 1945, the U.S. Army Air Forces detonated a uranium gun-type fission bomb nicknamed Little Boy over the Japanese city of Hiroshima. 3 days later, on August 9th, the U.S. Army Air Forces detonated a plutonium implosion-type fission bomb nicknamed Fat Man over the Japanese city of Nagasaki. These bombings caused injuries that resulted in the deaths of approximately 200,000 civilians and military personnel. The ethics of these bombings and their role in Japan's surrender are subjects of debate. Who has nuclear weapons? The United States was the first country to develop nuclear weapons, detonating the first fission device in 1945. 7 years later, the United States successfully tested the first hydrogen bomb during Operation Ivy. As of 2018, the United States had an estimated 6,500 nuclear warheads, including retired, stored, and deployed weapons. The Soviet Union first developed nuclear capabilities in 1949. Russia's modern-day arsenal includes an estimated 7,000 warheads. France, China, the United Kingdom, Pakistan, and India also have nuclear weapons. Israel has not officially acknowledged its nuclear capabilities. Estimates of its arsenal have typically been around 80 warheads, although some estimates are significantly larger. North Korea's capabilities are largely unknown. It's suspected it may have a limited arsenal of 5-10 weapons, but may have material to build twice that many. How atomic bombs work. All nuclear weapons use fission to generate an explosion. Little Boy, the first nuclear weapon ever used during wartime, worked by shooting a hollow uranium-235 cylinder at a target plug of the same material. Each piece by itself was not enough to constitute a critical mass, but by colliding the pieces, critical mass was reached and a fission chain reaction occurred. Modern nuclear weapons work slightly differently. Critical mass depends on the density of the material. As the density increases, the critical mass decreases. Instead of colliding two subcritical pieces of nuclear fuel, modern weapons detonate chemical explosives around a subcritical sphere of uranium-235 or plutonium-239 metal. The force from the blast is directed inward, compressing the pit and bringing its atoms closer together. Once dense enough to reach the critical mass, neutrons are injected, initiating a fission chain reaction and producing an atomic explosion. In fusion weapons, the energy from an initial fission explosion is used to fuse hydrogen isotopes together. The energy released by the weapon creates a fireball that reaches several tens of million degrees, temperatures in the same range as the center of the sun. Warheads in depth. The explosions used in thermonuclear weapons are often described as a primary and secondary. However, the actual mechanisms are considerably more complicated. For example, a pure fission primary is inefficient. The plutonium pit will blow itself apart before most of the plutonium-239 can fission. Instead, the reaction can be boosted by including hydrogen gas in the center of a hollow pit. As the surrounding plutonium fissions, the hydrogen gas undergoes fusion and releases neutrons, inducing additional fission. Similarly, the secondary doesn't consist purely of fusion fuel. Layered within it is a fission spark plug, consisting of either plutonium-239 or uranium-235. As the primary explosion compresses the fuel from the outside, the spark plug material becomes supercritical and fissions, heating the hydrogen from the inside and facilitating further fusion reactions. What should we do if there is a nuclear war? If a nuclear blast is on the cards, then it could take place without lengthy warning. Therefore, if you think an attack is likely, it is best to be prepared. Experts recommend you follow the guidelines below to protect yourself, your family, and your home. If you believe an attack is imminent, build an emergency supply kit, which includes items like non-perishable food, water, a battery-powered or hand-crank radio, extra flashlights, and batteries. You may want to prepare a kit for your workplace and a portable kit to keep in your car in case you are told to evacuate. Make a family emergency plan. Your family may not be together when disaster strikes, so it is important to know how you will contact one another. how you will get back together and what you will do in case of an emergency. Find out from officials if any public buildings in your community have been designated as fallout shelters. If none have been designated, make your own list of potential shelters. These places would include basements or the windowless central area of middle floors in high-rise buildings. Nuclear holocaust. A nuclear holocaust, nuclear apocalypse or atomic holocaust is a theoretical scenario where the mass detonation of nuclear weapons causes globally widespread destruction and radioactive fallout. Such a scenario envisages large parts of the Earth becoming uninhabitable due to the effects of nuclear warfare, potentially causing the collapse of civilization and, in the worst case, extinction of humanity or termination of life on Earth. Besides the immediate destruction of cities by nuclear blasts, the potential aftermath of a nuclear war could involve firestorms, a nuclear winter, widespread radiation sickness from fallout, or the temporary loss of much modern technology due to electromagnetic pulses. Some scientists, such as Alan Robock, have speculated that a thermonuclear war could result in the end of modern civilization on Earth, in part due to a long-lasting nuclear winter. In one model, the average temperature of Earth following a full thermonuclear war falls for several years by 7–8 degrees Celsius on average. Early Cold War-era studies suggested that billions of humans would survive the immediate effects of nuclear blasts and radiation following a global thermonuclear war. The International Physicians for the Prevention of Nuclear War believe that nuclear war could indirectly contribute to human extinction via secondary effects, including environmental consequences, societal breakdown, and economic collapse. It has been estimated that a relatively small-scale nuclear exchange between India and Pakistan involving 100 Hiroshima-yield weapons could cause a nuclear winter and kill more than 1 billion people.